Right, ladies and gentlemen, we have Lex Hider here to talk about Conda cross-platform language agnostic package manager. Lex knows a lot about computers as he has a beard. He hacks data for a living in Melbourne, and I'll just hand this off to Lex.
Hi. So I'm here to talk about Conda. Can you all hear me okay? Yes. So my name's Lex Hider. That's where you can find me on GitHub and Twitter. I'm okay at technology and things. I'm not great on PowerPoint, so sorry if my slides aren't the easiest to read. They're online though if you want to follow one of those links. I've also put that on Twitter. If you check out hashtag pycon-au, you'll find it, I think. Let's get started. So a quick quiz. Who here uses pip? Almost everyone. Just in case you don't know what pip is how Python programmers install packages, essentially. Who here uses virtualenv? Almost everyone. So again, if it's not something you're familiar with, virtualenv is a way of not having a shared place where you install your packages. It's a way of having those isolated. So you could, if you're a Django developer, you could have a Django 1.4 virtualenv where you do development for one customer and Django 1.8 in another, for example. So if it's not something you've heard of, it's a really good thing to be using, although hopefully after this talk you might consider using Conda instead. So the TLDR version of my talk is Conda. If pip and virtualenv got married and had a baby and you fed it steroids, that would be Conda. He must work out. Second version of the TLDR one is that it's like a cross-platform homebrew written in Python. But it's not just limited to Python packages, it can install anything. So just to clear up some things about Conda, so you may or may not have heard of Condor or Anaconda. Who here has used Conda before today? Okay, probably half the people. So there's three things that sort of people talk about, and it can be a little bit confusing which one's which. So Conda is a tool, like pip is a tool, or homebrew is a tool, or apt-get is a tool that you use to install packages. It also does that thing that virtualenv does, where it isolates different installations of things. Anaconda is an installer for the Conda tool that also comes bundled with sort of the 200 most popular SciPy Python data packages sort of already on there for you. And then mini Conda is like a mini install. So if all you want is Conda, it's only a 30 meg download, and you can just install and download what you need as you need it. So is this just another not invented here? Are they just reinventing a wheel and just doing this for no reason? Travis Oliphant, he runs a company called Continuum.io. They're doing lots of interesting things on the cutting edge with Python and data and things, and specifically sort of scientific type stuff. He's essentially the original author of NumPy. And from a blog that he wrote, several of us asked Guido what we can do to fix Python packaging for the NumPy stack. Guido's answer was to solve the problem ourselves. We at Continuum took him at his word. We looked at dpackage, RPM, pip, virtualenv, brew, Nixos, and Zero installer, and used our past experience with EPD. We thought hard about the fundamental issues and created the Conda package manager and Conda environments. So Conda is the answer. This is my third version of the one-liner talk. What is the question though? So before afternoon tea in here there was a data science tutorial. Did anyone here attend the tutorial? A handful of people. I didn't attend either, but apparently it was 100 minutes sort of taking people through sort of your first steps with things like machine learning and data analysis, and sort of data science is, you know, the cool new buzzword thing. So anyway, to be able to partake in that tutorial, you need these are the packages that you need installed to be able to follow along. So there's 13 of them. Some of the sort of big hitters in the scientific Python world: NumPy, Pandas, scikit-learn, and then there's a few more niche ones. So as an exercise, I went through and, you know, pip is how you install packages. Let's see how we go using pip to get our 13 packages installed so we can follow along with something like the tutorial that was here before. So I wrote a script. This one is just pip installing those requirements. Now this is running on my MacBook Pro here. It's an i7 on OS 10. Took about half an hour. Part of that was probably crappy internet, and it's succeeded. I just wanted to get a cricket reference in there. Alright, so that worked on OS 10, but not everyone has OS 10. Some people might be running Linux, or it's almost certainly that you'd be running Linux servers and not OS 10 servers, so let's try that. Same code. I spun up a Linux virtual machine. 8.5 minutes later, I got this cryptic error message. So don't worry if you can't see these stack dumps, it's just sort of illustrative purposes. And that made me sad. So I did some Googling. It turns out that I needed package config, so version 2 does that. 6 minutes later, another cryptic error message. Version 3, some more Googling. Oh, we need free type. Okay, let's install that, see what happens. 12 minutes later, fail. I was doing this yesterday while I was watching some of the talks, so I was getting more and more frustrated. Version 4. I particularly like that I ended up on the Linux for Noobs Reddit to find my answer for that last failure. How did we go? This one took 90 seconds and it failed. I don't know if people can read that, but can anyone see why that has failed? No Fortran compiler. So I think that's for SciPy. I think you need Fortran to get SciPy installed because it's still 1969. So let's install Fortran. 3.5 minutes later, fails. This time it was quite easy. We didn't have G++ installed, so let's try that. Let's install G++. 6 minutes later. Can anyone tell me why this one has failed? So I had this is on a Linux virtual machine on my laptop, and I had 1 gig of RAM, and apparently that's not enough. So, changed it to 2 gigs of RAM. Let's try again. Took 12 minutes, and it failed. I thought maybe that was the last one. Anyway. Getting more and more angry. Some Googling said I needed to install something else. Details really aren't important. 4 minutes later, hey, all my stuff is installed. So it only took me around about an hour, excluding the time I spent Googling it, the problems. And I tried it again, a fresh install, just to see how long that script takes kind of end to end. This kind of used the cached download stuff, so this excludes the download. Takes about half an hour because it's running all these scripts.
What version of that?
Latest, or very, very, if not the very latest, closest to. So, is the problem solved? So I went back to OS 10 and we'll be using Python 3, not Python 2. Alright, let's try that. Let's try pip install Python 3. I don't know if you can read that one. Can anyone tell me why pip install Python 3 didn't work? Sorry? Okay, so what do we do? There we go. We turn to Conda. So just to reiterate, Condor is the tool. Anaconda is a collection of common packages that they provide. Miniconda is a minimal way of installing it. So think of, if you know about Linux distros, Miniconda is like a little tiny server ISO to install, and Anaconda is like a big install ISO with all the things that you need. So let's try the same exercise but with Conda. So how do you install Conda? You download a bash script. This is on Linux and OS 10, and you run that. You now have Conda installed. And then you run these commands. This is Conda create. You give it a name and what packages that you would like installed. This is going to install Python 3 into an environment called Data Science Tute. And so a Conda environment, think of it like a virtualenv if that's what you're familiar with. This is how we get inside the environment that we've just created. So now we're in the environment and we're using Python 3 that we installed. Conda install all these things. Now, of the 13 packages that we're dealing with, someone can count them up, but most of them are available on Conda. They have Conda packages, but not all. So we did that. If a Conda package doesn't exist, though, you can still use pip. So we install pip, and we install the other things that Conda packages don't yet exist for. So that took, this is excluding download times, which is, about 90 seconds, and most of that was actually in the pip install part of it. Pretty much everything you need to know about Conda as an end user is on this slide. Install Conda, create an env, get inside it, install some stuff. But we'll go over in detail all these steps as well. So there's a nicer way of doing what we just did. You can, these environment YAML files, you can write one of those. So we give a name to our environment, which is Data Science Tute. We list our dependencies and we can say which version. So we're going to install Python 3.4, IPython notebook, maps.lib, and then from pip, we're going to install the remainder. I run one command, conda env create this file, and in one line it's done what we did before, and happy days. Okay, live demo time. Fingers crossed that I have a working internet connection. Is that readable? Not too bad. Okay, so I've already got Conda installed. So Conda Create will create one of these environments for you. So an environment is an isolated place for you to install packages. I give it a name, and I say what packages should be there to start off with. So we'll just start with the minimal one. We just want Python. We want Python 3. We could say different versions of Python. This will just get the latest Python 3 that it knows about. So let's do that. Done. Okay, and you can see that it's told me how I get inside my environment, so that's not something you even sort of need to learn at the start. And you'll see that it's changed my prompt, so now I know that I'm within my demo environment. And now I can just install things. So let's install, if people don't know pandas, there's a data analysis library. IPython's like a better REPL for Python. Let's install those. I think the slowest thing here is going to be the Wi-Fi. Done. That's all it takes. Now, this is Python things. We have installed though a different version of Python with Conda. It doesn't have to be Python things at all. There is a statistical language called R, which is quite popular for data and statistician people. So let's install that with R. Again, I think the slow part is the Wi-Fi.
This is all going into the demo sort of work environment.
Yep.
Okay.
Done. And I've got my R. Let's get this environment that I'm in. Did it do that? No. So this is how we got inside the environment. This is how we get out, or we close the shell. Alright, so back to my slides. I think I've covered this enough. Conda's the tool. Anaconda is common packages bundled up. Conda is a minimal way of installing it. My recommendation, go for Conda and then just install what you need. It's a 30 meg download to get started. That's what I do. Alright, so some of the details. So you download a bash script and you run it. It will install it by default to, in your home directory, a folder called Conda. You do not need root privileges to do this. It's just going to install it in your user's home directory. So that's one of the big wins with Conda, is you don't need root privileges. I was talking to someone yesterday and they had a Windows laptop and they used Conda. They didn't have administrator access. It wasn't a problem. So that installs it into the Conda directory in your home, and then and it'll prompt to do this for you. You just add Conda/bin to your path. Now, because everything happens inside this Conda, if you try out Conda for a day or a week or a month, you don't like it, you want to uninstall it, blow away that directory, it's gone. So yeah, Conda Create, it's like a virtualenv. So there's these isolated places for you to download and install things, and you can have Python 3 over here and Python 2 over here, and different versions of things, and one doesn't know about the other. So Conda Conda create, tell it what you want to call your environment and what packages to install initially. And this is going to create a directory in miniconda/env and then the name of that you give it. To remove environments, there's 3 equivalent ways of doing the same thing here. I actually just do an rm that directory. I haven't actually memorized the other ones, but they're the same way of doing the same thing, get rid of the environment. To get inside your environment, we covered this before, source activate my environment. It'll actually prompt you about that once you create a environment, and it'll put a little thing in your prompt telling you that you're inside it. And as I said before, you can get out of it as well. Now, if you're running a script or something, you don't even have to do that. You can just give it the path to your environment's bin directory to run your script, and it will use that environment to do what it needs. So to install some stuff, Conda install package name. What this does is downloads a tarball to Miniconda packages. It untars it, and one of the reasons that it was so fast before with installing things is because it hard links from there into your environment. That's how, so if you have 5 environments with pandas installed with the same version, it's just a hard link to all 5 of them. So it's really fast and it doesn't eat up your hard drive space. Experimenting with different environments. So Conda, pip, and virtualenv, how do they work in together? So since switching to Conda, I don't use virtualenv anymore. Conda kind of does what I need as far as isolated environments. Conda packages don't exist for all the packages yet, but for a lot of the ones that I do use, there's now Django packages, there's now lots of software that I use that do have them. For everything else, you can do Conda install pip, and then pip install those, and it's worked fine for me so far. Conda can update itself to the latest version. It can update specific packages, and it can update everything that you have installed. If you're familiar with pip, you can do a pip freeze, and that'll tell you everything that you've installed so that you can have a reproducible build. This is the Conda equivalent, Conda list export, and you can pipe that to a file, and then Conda install, and you give it a file that you want to install from. Now there's a similar thing here which will create that YAML file that we spoke about before, so Conda env export, and that will spit out a thing with the name and the dependencies as a list, and then also which ones came from pip. And then it's a one-liner to install from there. We covered this in the demo. You can install things that aren't from Python, and you can use different channels, and you can create your own channels, so that's really easy to do too. So if I wrap up, I've covered here OS 10 and Linux. I spoke to someone though yesterday who's had really positive experiences with Windows, so it's completely cross-platform in that way. You don't need root or admin privileges. It doesn't have to be Python code. It can be anything. We installed R4, there's MongoDB, there's no limits there. So some of the advantages that I found is faster deploys. A pip install and then wait 10 minutes or 20 minutes is not great when I can spin up an AWS machine in 2 or 3 minutes. And faster debugging between versions. So if I quickly show you as an example, so we installed pandas before, and the latest version of pandas is 0.16.2, I think. Let's say I found a bug and I want to see if it was in the last version. I've just switched back. I can run my test case, see if it works, and switch back and see is there a difference. So I found it really great for debugging and fast switching between them. It's not going to run the pip script all over again. Been using it in production for 18 months without any hassles, and it had some big wins for me. Building is easy too. I haven't got time to cover that today, but if you read the docs are quite good. And they also have anaconda.org as a place to upload and share packages. I think I'm out of time to touch on building, but if anyone has any questions, go ahead.
Yeah, oh, one sec.
Thank you. That was a very practical talk. So, from what I understand, data analysis is mostly performed on desktops, like exploratory wise. Do you also use Conda on servers, you said?
Yep.
And it works fine?
Yes.
So, but there's something that it seems to me that if it works via hard links, then it has to have downloaded all the packages in advance. So all the time you save is because you did the download once, and that was a longer download, supposedly.
Yeah, so it's the same with pip though as well. Like you need to go fetch the packages first, and so I didn't include that in my benchmark before. But yeah, so you do need to download those first. They're just stored in. So you'll see in there, that's where the tarballs get downloaded, and then they get untarred. So you could tarball that up if you wanted to, and make that part of your deploy if you wanted to speed up that step of downloading stuff. But that tends not to be the slow part in that half-an-hour script before the pip install everything. That was because it's running scripts every time. This is binary distribution.
And one more question. I do teaching, and nowadays students bring their own laptops, and some are Windows, some are Mac,
Yep.
and even some Linux. Could you expand, apart from the problems they had installing because of the different prerequisites on Linux, whether Windows uses this real parity once everything is installed between all of them, or whether you see differences during usage? And I'll give up the microphone.
Yeah, sure. So I think Andrew here was actually a Windows user. I'm not, so I haven't done testing firsthand, but he might have a first-hand experience to be able to share.
Yeah, it's definitely a first-class experience on Windows, where it's traditionally been exceptionally hard to actually get NumPy built. The only way that I knew to do it was to actually download either the individual packages and then install them using their executables or using the super pack. This just makes it so much easier. In fact, it's really the only practical way to do this on Windows these days.
And yeah, so I haven't got first-hand experience of running it myself, but we had a case at work recently where we did some analysis, and then the client wanted to have a look at that, and they were running Windows, and they were able to reproduce our analysis that was done on Linux and OS 10 on a Windows machine.
Did you say the Conda packages are binary packages?
It's basically just a tarball. So well, what I didn't get to cover is a package is basically a tarball with an info directory of some metadata about the package, and then just what's going to essentially get copied into that environment. So bins/lib/share.
So as a corollary of that, are the Conda packages specific to the environment that you install? So do you need a Windows Conda package and an OS X Conda package?
Yeah, so I think there's essentially 5. You've got Windows, there might be OS 10 for the 64 and 32, or maybe they're just 64, and then there's Linux 32 and 64 that get built. But the build tools allow you actually to generate all of those, specifically if it's not sort of binary files that's required. So for a Python package, on my Linux or OS 10, I can create a package and convert it to all platforms and distribute that. But yes, each one will download one specific for that architecture.
We've actually got a few more people who want to ask questions, but we're running out of time. So are you okay to take questions later, or?
Yeah, yep.
So you guys can just meet up with Lex. Lex Hider, tell him more.